So lesson 6.1 is about reciprocal, quotient, and Pythagorean theorem identities. So a trig identity is an equation that is true for all permissible values, and we have to make sure that the left side of the equation equals the right side of the equation. So when the expressions on either side of the equal sign are evaluated for any permissible value, then we know that the left side will equal the right side. So we need to take out the non-permissible values, and we need to find out what values are allowed, where that if you do this algebraically or graphically, that the left side does equal the right side. So these are known reciprocal identities. So cosecant right here is equal to 1 over sine x. So if you flip sine over x, it's the reciprocal of it. Secant is the reciprocal of cos, which is 1 over cos x, and cotangent is 1 over tan x. And then the quotient identities are where tan x is always equal to sine x over cos x, which means that cotangent would be the reciprocal of that same fraction, which is then cos x over sine x. So these are important ones to note and keep in mind as we continue. So example number 1, they want us to determine the non-permissible values in degrees for this equation. So when we're putting this into our calculator, or when we're actually looking at this, we need to look at cotangent of x as 1 over tan of x. So for this to be true, the non-permissible values would be anywhere the denominator is equal to 0, which in our case, our denominator, which is sine of x, is not allowed to equal 0, right? So we need to find out every value of x that does make that equal to 0. So if I were to look at the sine graph, I know that every 180 degrees, there is going to be an x-intercept. Okay, so I know that at 0 there is an x-intercept. If I graph this, there would be one at 180 just by knowing the sine of x graph. This would be 360. So x is not allowed to be, if I were to create a general equation for this, it would occur every 180 degrees. And n is an element of integers. Okay, so every 180 degrees, we know that there is going to be a non-permissible value when you're in degree mode for this equation. Now they want us to verify that x equals 45 degrees and x equals pi over 6 are solutions to the equation. So what I can do is I can plug in 45 degrees and I can plug in pi over 6 to see if left side equals right side. So if I'm doing the 45 degrees, it's really easy to do that in your calculator. So I would go 1 over tan of 45 degrees. I would put that into my calculator. So 1 divided by, make sure that you're in this case, you need to be in degree mode if you're doing this first question. So 1 divided by tan 45 in brackets gives us 1. So that's the left side of the equation. The right side of the equation will be where I have to put cos 45 degrees divided by sine 45 degrees. So if this identity is true, or if that value is true, then I know that left side would equal right side. So I'm going to go cos 45 divided by sine 45 in my calculator. And I should also get 1, which means that left side equals right side. So we did verify for the x equals 45 degrees, that works. Now we have to do the exact same thing for pi over 6. Now with questions like this, I find it helpful to then use, you could use your special triangle if you wanted to find out those values, or you could just put them into your calculator or use your special triangle. Yes, your special triangle angles or your unit circle. Those would be your options for this pi over 6. So for the left side, we know that we're plugging in 1 over tan of pi over 6. Now, if we draw the triangle for pi over 6, it's going to look like this. Pi over 6 is the same as saying 30 degrees. And 30 degrees should always be opposite to 1. Our angle opposite to 90 degrees should be 2. And then opposite to pi over 3, which is 60, should be root 3. Now, when we do this special triangle, I always divide these values by 2 so that it's rationalized. So this will equal then 1. So I always want the values to be rationalized, so this kind of does that for me if I divide all the values by 2 in the end. So when we're looking at 10 of pi over 6, that's equal to your opposite side divided by your adjacent side. Okay, so what I'm going to do is I'm going to go 1 has to be divided by, in brackets, opposite, which is 1/2, divided by our adjacent side, which is root 3 over 2. So I'm going to continue writing this over here. It'll be 1/2 multiplied by 2 and then divided by square root of 3. These guys will cross each other off. So it's going to be 1, and then I'm going to have to multiply by, I'm going to have to flip 1 over root 3 to become root 3. So I know that this is going to be just root 3 from 10 of pi over 6. 1 over 10 pi over 6 is going to equal root 3. So that's the left side of the equation. Now I need to do the same thing for the right side of the equation, but I'm going to have to do cos of x. So that's going to be cos of pi over 6, and I'm going to have to divide it by sine, running out of space here. Let me actually just add a page, and that will make it easier here for me. Okay, so I'll just continue that over here. So I know that cos pi over 6, I'm dividing by sine pi over 6. Now my goal is to get root 3. If I get square root of 3 as my answer, then I know that left side equals right side. So when I'm looking at my triangle again, I'm just going to redraw that. We have pi over 6 is opposite to 1/2. And then we have our pi over 3 is opposite to root 3 over 2. And our hypotenuse is 1 in this case. Okay, so when we're looking at pi over 6, cos is going to be our opposite side, our adjacent side divided by our hypotenuse. So that's going to be root 3 over 2 divided by 1. So that's just going to be root 3 over 2. Divided by sine pi over 6 is opposite over hypotenuse. So that's just going to be 1/2. So when I actually solve this, we're going to have to do root 3 over 2 multiplied by 2 over 1. So those are going to cross each other off, leaving us with root 3 over 1, which is root 3. So I just found that left side equals right side. Okay, so I just confirmed that that does work. Now, if I want to check this graphically, I can put y1 as the left side. So I would go 1 over 10 of x. And then y2 is the right side of the equation. So I would go cos x over sine of x. They want us to use the domain, so for my window, I would have x go from negative 360 to positive 360, going up by 30 degrees possibly. And for y, I can go from negative 5 to positive 5, going up by 1. So if I use this, if I put y1 as one equation, y2 as the other equation, what you should find if you're checking, if you're confirming that these are identities, is that one graph should go over the other graph. So they should overlap. So therefore, graphs overlap. Therefore, they are equal to each other. Left side does equal the right side of itself. Example number 2, they're giving us secant x. So we're going to rewrite this. So secant x is like saying 1 over cos of x. Divided by tan of x is the same as saying sine x over cos x. Now when I actually, what I like to do is I always like to change this to multiplication. So I'm going to flip the second fraction. So 1 over cos of x, we're going to multiply by cos of x over sine of x. So I'm going to leave it like this because this is where I can see the non-permissible values. These are my non-permissible values, all these levels here, because cos of x is in the denominator, and whenever you flip something, you have to look at the top and bottom of that fraction. So in this case, I'm looking for values that make cos x equal to 0 and values that make sine x equal to 0, because those will give me my non-permissible values. So in the previous question, we already found when sine is equal to 0, so we knew that that was every 180 degrees. So I know that it was 180 degrees and NEI, actually. So it's every 180 degrees. So that would be where x is not allowed to be, what x is not allowed to be. So the next case would be if you were to draw the cos graph. The cos graph always starts from 1 and then it goes down and it hits that x-intercept at pi over 2. And it comes back through the x-intercept at 3 pi over 2. So this one is pi over 2, and if you add 180 degrees, that's going to take you to the next one. So if you look, if we're talking about 90 degrees, and then 3 pi over 2 is like is 270 degrees, and then 180 degrees from this one would be here, and 0 would be here, it will take every single value, every quadrantal angle going around will be targeted. So all these angles here will be part of the solutions for this, this one right here. So if I want, I can cross this off and summarize that every 90 degrees, meaning x is not allowed to be pi over 2n NEI. What this means is that every 90 degrees, there is a non-permissible value. So that takes into account the cos x graph and the sine x graph, because I know that sine is every 180 degrees and cos is going to be every is 90 degrees, and then the 270 degrees, and then it goes around and around and around. But if I do every 90 degrees, that answers all the questions. So this summarizes all the answers that I actually need for this. So I'm going to put a box around this as my final answer. So in the next case, they want us to simplify. So simplifying just means that let's cross off what is in the way. So I have 1 over, I already got to this part where I had 1 over cos x times cos x over sine x. Well, whenever you have something in the denominator and something in your numerator that are identical factors, you can cross them off, leaving us with 1 over sine x, and that's equal to cosecant x. So that would be the simplified version of this. Okay, so I've just simplified it to one trig identity. The next one is using Pythagorean theorem identity, where we always know that on the unit circle, we always have x squared plus y squared equals 1 squared. Well, x is always cos and y is always sine on the unit circle. So we can replace x and y with cos and sine. So what they've done is they've said cos squared theta plus sine squared theta actually equals 1 as well. So we can use this to replace different values here. So what we're going to do for this one is for example number 3, we're going to verify the equation numerically by putting in 3 pi over 4 to see if left side equals right side. So I would do 1 plus 10. In x, I'm going to go 3 pi over 2, or 3 pi over 4. And this answer is going to be squared. So this really just means that the whole answer is going to be squared whenever you see that. And we're saying, is it equal to secant, which is the same as saying 1 over cos, so we can replace that. 1 over cos, 3 pi over 4. And this is going to be all squared as well. Okay, so that's what that really looks like. Now, if you look at the unit circle, we know that 3 pi over 4, if we actually do 10 of it, or if we put that into our calculator, so if you evaluate within radian mode, so if you go to mode, change it to radian mode, and then put 10 3 pi divided by 4 in your calculator, you should get -1 as the answer. So we know that the left side okay, there you go. So the left side is equal to then 1 plus tan 3 pi over 4 is equal to -1, and we're going to square that value. When we square -1, we get 1, so 1 plus 1 is 2. So that's the left side. That's what the left side is equal to. Now the right side. The right side, we're taking 1 and we're dividing by cos 3 pi over 4. Now, 3 pi over 4 actually takes you into quadrant number 2. And if you look, the reference angle is pi over 4. So pi over 4 is going to take you up here. So we know that the answer for cos 3 pi over 4 will be a negative answer. And then whenever we're looking at pi over 4, we know that the triangle sides are going to be 1, 1, root 2, if you remember your special triangles. Now, we could divide it by root 2 if you wanted to, but we can leave it in this manner right here. Okay, so when you're doing this, you want to look at cos from pi over 4. So cos is equal to your adjacent side over your hypotenuse, which is 1 over root 2. So we're going to have to go 1 divided by 1 over root 2, which actually works out in our benefit because we're going to have to go 1 multiplied by the reciprocal of that second fraction, which is root 2 over 1. So we don't have to do that. We don't have to multiply that. We also have to remember that this answer is going to be negative and we're going to have to square it. The reason being, the final answer is going to have to be squared. That's what I had to remember. So this one is going to be negative 1 over root 2, which is then 1 multiplied by negative root 2, which is negative root 2. And finally, we just have to square this value to get the answer for the right side. So a negative squared becomes positive and a square root gets canceled. So you're going to be left with 2 as the right side. So you could definitely put this into your calculator just to see that left side equals right side. So that would be a faster kind of method instead of just using this kind of special triangle, but it does say to do this numerically, which is another name for algebraically. Express the Pythagorean identity cos squared x plus sine squared x equals 1 as the equivalent identity 1 plus tan squared x equals secant squared x. So they're asking us to kind of replace this. So what I would do is I'm trying to get it to look like that. So we want to express this one as the other one. So first of all, we know that to get, let me write it out here. So step 1, in order to get it to look like this one to look like that, I'm going to have to take cos squared x plus sine squared x equals 1. What I'm going to start by doing is I'm going to divide everything by sine squared x, because we don't have that. We don't have any sine squared x in any of the parts. We only have cos if you look, because secant is the reciprocal of cos. So what I'll do is I'll divide this one by sine squared x, this one by sine squared x, because as long as you do it to everything, it's still equivalent. So what this will do is this will become 1. And then here, cos squared x over sine squared x is the same as cotangent squared x. You can leave it like that for now if you wanted to, but what I'll do is just leave it. So cos squared x over sine squared x plus 1 equals, and then since I divide 1 by sine squared x, Actually, I think it's better. I just looked at it. I think it would be better, guys, if I divided by cos. I just realized that. So I'm going to divide all these values by cos squared x. It would be way faster, and you'll see why. So this will save me a lot of time. So cos squared x divided by cos squared x will be 1 plus sine squared x divided by cos squared x will be just tan squared x. And then 1 over cos squared x is just secant squared x. So that's it. That's all I had to do is divide all of them by cos, and that gave me what I actually wanted. So that was way faster. The other one, I could have done it. I would just have to do one more step after the other one. So it would be a 2-step problem versus here there was only 1 step. The next one is we're going to look at the 3 forms of the Pythagorean identity, which is the one we just looked at, which is cos squared theta plus sine squared theta equals 1. Then there's cotangent squared theta plus 1 equals cosecant squared theta. And that's what I would have gotten if I had divided all those values by sine squared theta like I was starting to. That would have given us the second identity. And this one right here, this identity, I just divided everything by cos squared x to get that. So it says, show algebraically that one side is equal to the right side, for example number 4. So this is an identity, and we want to prove that the left side equals the right side. So step 1 for this example is I'm going to work on getting common denominators so that I can join the tops together. So let's look at the left side first. The left side, I'm going to multiply the first fraction. So I'll write it out first though. So I'm going to multiply this fraction by 1 minus sine theta. What I do to the bottom, do to the top. And I'm going to multiply the right side of the that right fraction by 1 plus sine theta to the top and bottom. And so when I multiply the bottoms together, it becomes one common denominator. So I can write it as 1 minus sine theta multiplied by 1 plus sine theta. So that's one common denominator. And then multiplying by 1 at the top doesn't change it. So I'm going to have this at the top plus 1 plus sine theta. Now what you should notice is that these guys cross each other off, leaving us with 2 at the top of our fraction. Now, normally we don't try to expand the bottom, but in this case I will, because it will make it easier to look at. So at the bottom, if I actually multiply and do FOIL for the bottom, I'm going to get 1, and then I'm going to get plus sine theta, and then I'm going to get minus sine theta, and then minus sine squared theta. So these guys will cross each other off, leaving us with 2 over 1 minus sine squared theta. Now, looking at the above identity, if I rearrange them, I can find that if I move this sign to the other side, I'm going to notice that 1 minus sine squared theta is actually equivalent to cos squared theta. And 2 multiplied by 1 over cos squared theta is equal to 2 multiplied by secant squared theta, because that's the reciprocal function. And then that is the same as the right side. So then you're done. So that was the proof. That was how to show that they are identical, left side, right side. Okay, so that's it for 6.1. If you want to do some extra practice, there are examples below you can try, but that's it for 6.1.